How do airplanes fly? There is no net force on airplanes. Newton's first law says that an object at rest stays at rest, and an object in motion continues in motion with a constant velocity and direction, unless acted upon by a net external force. There are forces acting on the airplane. Gravity pulls on the plane and the people inside the airplane. Air molecules shoot from the engines, which collide with the wings and pushes the plane up. If all these forces are in balance, then the air molecules push the plane up enough to counteract gravity. There are four main components to how a plane flies: thrust, drag, lift, and gravity.
Thrust is when an object is pushed forward with force. Planes use their jet engines to achieve thrust. The engines suck in air, compress it, mix it with gas, and ignite the mixture in a burst of energy that shoots at the back of the engine, which pushes the plane forward. If you've ever watched a jet plane taking off or coming in to land, the first thing you'll notice is the noise of the engine. Jet engines, which are long metal tubes burning a continuous rush of fuel and air, are far noisier than traditional propeller engines. You might think that engines are the key to making a plane fly, but you'd be wrong. Drag, with all the air molecules crashing to lift the plane, it also pushes to slow the plane down. It would, but that's why there are engines. Engines also push air, either with a propeller, jet, or jet driving a propeller.
Lift is the force that drives a plane upward and keeps it in the air. In order to produce lift, planes rely on their wings, which have a special shape called an airfoil. The top of the wing bulges out to create a smooth bump. When the wing moves through the air, incoming air particles either go above or below it. Thanks to the bump, the air on top of the wing moves faster than the air on the bottom. These particle speeds create lower air pressure above the wing and higher air pressure underneath it. This concept is called Bernoulli's principle. The high air pressure pushes the wing up, creating lift. An airfoil splits apart the incoming air, lowers the air pressure of the upper airstream, and accelerates both airstreams downward. As the air accelerates downward, the wing and the plane move upward. The more an airfoil diverts the path of the oncoming air, the more lift it generates. Thrust and lift are always fighting two other principles of aerodynamics: drag and gravity. Drag is when a moving object blocks the flow of air, slowing the object down. You can feel drag if you put your hand out the window of a moving car. Your arms get pushed backwards as the air rushes by. Planes need to have enough thrust to overcome the amount of drag it produces, so they're designed to have airflow as smoothly as possible around the body of the plane.
This is the lift equation. L equals lift in newtons, V equals velocity in meters per second, S equals wing area, meters squared, P equals free stream air density in kilograms over meters cubed, CL equals coefficient of lift. If a Boeing 747 has a wing area of 510 meters squared and is cruising at 263 meters per second, and the density of air is 1.2 kilograms per meters cubed, and the lift coefficient is 1, what is the lift?
Finally, this is the drag equation. F sub d is the drag force. C sub d is the drag coefficient. A is the reference area, P is the density of the fluid, and V is the flow velocity relative to the object.